Hello and welcome to this new video from IoTeX Lab Delegate. I'm very excited to show you this new tutorial as this is the foundation of my new project, a proof of concept based on the IoTeX blockchain to build a real-world Internet of Things application with the Raspberry Pi 3. If you like these videos, please remember to support IoTeX Lab Delegate by staking your tokens with us. Staking and voting on the IoTeX blockchain is very easy. Remember that you can create multiple buckets of votes and you can assign different buckets to different delegates. Now let's get started and see how we can install, configure and run an IoTeX Blockchain Full Node on the Raspberry Pi 3 board. Okay, let's start first with opening the IoTeX Lab website. Let's go on tutorials, find the running IoTeX Full Node on Raspberry Pi tutorial. Let's keep this page open for reference. So first of all, we are going to configure this Raspberry Pi in a headless mode. This means that we will not need any monitor, any keyboard, any mouse or whatever. We will only need our Raspberry and to connect it in the same local network as our computer. As a second note, we are not going to install the official Raspbian operating system. This is because there is an incompatibility between the architecture of the Raspbian operating system and the database used in the IoTeX Full Node, so it would not work. For this reason, we will install Ubuntu 18.04 ARM64 architecture for Raspberry Pi 3. So the first step to do is to download this Ubuntu image by clicking here, and then we will need also to download the Etcher utility. This is a very easy to use utility for flashing image files into SD cards. So click here and download Etcher. Okay, great. Let's get back to our tutorial. Open Etcher, open. Now select the Ubuntu image that we just downloaded. It already recognized the SD card, so we only have to click on Flash. Okay, this will take like 3 or 4 minutes. Now that our SD card is ready, we got to remove it from our computer and put it into the SD card slot of our Raspberry Pi. Then we will connect the Raspberry Pi Ethernet port to our router with an Ethernet cable. And finally, power on our Raspberry Pi. This will take like 1 minute to boot. So meanwhile, we can go on our router. This, depending on your network configuration, the address of your router could be different. Anyway, it should be similar. Okay, what we are looking for is to check connected devices. In this case, for my router, I go on Advanced, and then on Network, and then on LAN Settings. Here, I will see the list of connected devices, and I'm looking for this Ubuntu device, which is our Raspberry Pi, and this is the IP address that has been assigned from the router to the Raspberry Pi. Make sure you have DHCP enabled on your router to make this work, and then we want to reserve this IP address for our Raspberry Pi. As you can see, I already did it. I went into the reserved address in my router and reserved the 105 address to this MAC address, which is actually our Raspberry board. And this is definitely required because we want to also direct all the communication with the other IoTeX blockchain nodes to our Raspberry. So we need to first fix the local IP address of our board, and second, we want to go on NAT forwarding and virtual server and set up this port so that all the incoming connections to this port of our router will be redirected to this IP address of our Raspberry Pi. This is the port on which the IoTeX Full Node is running on our Raspberry Pi. This is absolutely required, otherwise our node will not be able to communicate with the other nodes in the IoTeX blockchain. So we are all set with our router. Let's go back to our tutorial. Our Raspberry should have already boot. So we will open a terminal window and connect to our Raspberry. Yes. The default user is Ubuntu and the default password is Ubuntu as well. Now, the first time that you log in, the system will ask for changing the default password. So the previous password is Ubuntu, and I'll set a new password. Okay, now we need to log in again with the new password. And we are ready to start configuring our system. First of all, we should apt-get update. Okay, and then we should do sudo apt-get upgrade. This will upgrade all the package of your system and will take quite some time. If you are running into production, you should definitely do this. I'm just going to skip it by now, and I will proceed with installing Golang. So let's download the package, unpack, and let's move the Go folder in a more suitable location. We will then configure our profile. We will copy these settings in the profile configuration, save with Ctrl X, Y, enter. Let's apply the changes and let's check that our Golang has been installed correctly. Okay. Now we should build the IoTeX node. The correct way to do this would be to make it on a different computer, more powerful one, and cross-compile to the ARM64 architecture. This will be definitely faster, but we will still do it on the Raspberry. This will require some time, and also the Raspberry Pi has quite few memory. We can check with free as you can see, a total of 900 megabytes, and available on this system only 790. Building this source code for the IoTeX core will require a few megabytes more than 790, like 10 megabytes more. So just temporarily I will configure some swap space on the system only for the purpose of building the node. So I'm not going to configure any system-wide setting for this swap file, just something for the purpose of building the source code. I'm configuring 1 gigabyte of swap file, but only really like 5 or 10 megabytes are going to be used. Okay. Let's enable our swap file. Okay, and let's check that it's enabled. Great, we have now 1 GB of swap file. We can go on and install some required packages for building the node. We can now clone the source code repository. Enter the directory. Okay, we will build the version 0.7.2, so we will check out this release. And this is the latest release at the moment, just it's still on testnet, will be upgraded on mainnet in a few weeks. So we will build this, that is the latest release. To build it, we need to export this variable and finally go with make. Okay, this will take quite some time. We are at the end of the building of the node. As you can see, the script has started the tests. This will take still a long time to run, so since we are not really interested in tests that I can assure will pass, we can just press Ctrl+C to stop the execution and move on with setting the environment for running the node. So first thing, we will move the command line tool that has just been built to a different location so that we can call it from everywhere. We get all the folders ready. Okay, so now we are going to download some files that are specific to the testnet. When this release will be ready for mainnet, I will update this tutorial and I will put here the links for downloading the correct files for the mainnet. So by downloading these two files, our node will run on the testnet. And finally, I will download this file that contains the most current snapshot of the database. Otherwise, it will take really a long time to synchronize the node with the blockchain. Now we unpack the data. Now that we have all the files and folders in place, we only have to edit our configuration file for the node to run. To do this, we need one basic thing, that is our external IP address, which is the IP address of our modem router. Also, we will need to fix some directories into the config files, and finally we will also set a private key for a wallet that we will associate to our full node. This is not really required, but we will do it anyway because we will use it in future tutorials. So let's first of all configure the command line tool to point to the official team node of the testnet. This way we can use it to generate a testnet account that we will call operator. It's asking for a password where that will be used to store the private key of this newly created account. If we want to see the private key that we need to put into the config file, we can run the command account export. This is the actual wallet address of our account. It's asking for the password, and here it is the private key. Okay. Then we said we need our public IP address that we can get with this command. Okay, here is our public IP address, and we can now edit our config file. Let's first copy the IP address and open the config file and set the address here, save, copy our private key, edit the file again, and put the private key here. Save, and I also like to put a comment with the actual wallet address for future reference. And finally, we have to set these settings in the config file to the correct paths. So edit the config file again, and we have to change this into this. Same here, same here, and finally here. Save, and we are ready to start the node. I prepared a GitHub repository with some script files to make your life easier. So let's create a bin directory in our home. Enter this directory, download the start script, make it executable, and we can finally test our node by starting it. So as you can see, it's synching. Actually, it's reading this data from the snapshot database that we downloaded. That's why it's so fast. Now that it seems to work quite well, we can stop it, and we can configure a service on our Raspberry so that this node will start every time the Raspberry starts. So we will point our command line tool to our local node so that in the future we can use it to query our node, our own node. We can download this file that contains the configuration for the service and move it to the correct folder. Let's see if it's in place. Yeah, here it is. So we can reload system control, enable our service, and if we don't want to restart our Raspberry, we can just start the service manually now. Okay, now everything should be set. We can check the logs of our running node with this command. So it's still synching. This process will last for some time. Now that the blockchain is fully synced, let's query the node on our Raspberry with the IOCTL command line tool to take a look at some basic informations. For example, IOCTL BC info. This gives us the block height, the current speed in terms of transactions per second, the epoch number, and so on. Then we can take a look at the balance of our operator wallet with IOCTL account balance operator. That of course is empty. And we can take a look at the delegate nodes running on the testnet. So IOCTL node delegate. Okay, we have 28 delegates running on the testnet on epoch 1242. And finally, we can take a look at the CPU usage of this IoTeX Full Node running on the Raspberry 3 with 1 GB of RAM. We will use the utility HTOP. As you can see, it's only using like 300 megabytes out of 900 available. Actually, it's much less because I believe 100 and some more megabytes were used by Ubuntu. So it's like less than 200 megabytes. Also, the CPU usage is very low. Okay, as a last thing, we can close this session with our Raspberry. And from our MacBook, we can also query the full node, of course, with IOCTL. I have the same tool on my computer, so I will direct it to the Raspberry with the IOCTL config set and point. Okay, I'm now going to query my full node on the Raspberry from my MacBook with IOCTL BC info. Okay, great. Thank you for watching this video. In the next tutorial, we will see how we can use this Raspberry Pi and the IoTeX blockchain to open and close a simple door lock. Also, please check out this tutorial article on the IoTeX Lab website, as I will update both the article and the GitHub files. Thank you again for watching, and I will see you soon.